Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuhu. In the previous discussion, we completed multiplication rules in probability theory, and also we solved a few examples where we talked about contingency table. So today we are interested in learning tree diagrams. So let us see what we mean by tree diagrams. And we are interested in solving an example which will help us in understanding the concept in detail. So what are these tree diagrams? Tree diagrams are basically the diagrams in which all possible probabilities are covered. So where we write down all possible probabilities. That tree is called tree diagram. So because it look like a tree, it look like a tree like this. If you see, this is the tree diagram, starting from some stem, and then there are branches, and then further branches, and these are the giant probabilities. Okay, and the sum for these giant probabilities will always equal 1 because all possible outcomes will be covered by this tree diagram. So you can see this example. I have solved it in self-review 5-7. We solved this example, the example and the self-review. And this tree diagram is same for these two, where we have covered few situations. So the remaining situations are also there in the tree diagram. So you can see it at home, and there is also self-review. You can also see this, and I am interested in solving this example, question number 29. So I have pasted that question over here in Word. Let us see what is this. Each salesperson at Poche Sheets, so this is some name, and Hogan Insurance Agency is rated either below average, average, or above average with respect to sales ability. Each salesperson also is rated with respect to his or her potential for advancement, either fair, good, or excellent. These traits for the 500 salespeople were cross classified into following table. So this is the table where in total there are five, you can say, salesperson, and these are the traits or the characteristics that these salesperson have. Below average sales ability, 16 have below average. Let's say this 16 means 16 salesperson have below average sales ability, and at the same time, as fair is there, so potential for advancement for these 16 is fair. If you come to this 60 at the same time is explaining that 60 salesperson are there with an average ability of sales, and at the same time the potential for their advancement is good. Okay, so similarly, if you see this 45 means, or let's say 135, so 135 will mean that there are 135 salesperson with an above average sales ability, and at the same time the advancement and the potential for advancement in their career is excellent. Okay, so this is the table, and now let us try solving the questions. What is this table called? Yes, what is this table called? Anybody?
Tangency table, sir.
Contingency table. Contingency table. You can see from your previous notes that I have solved an example where I have used contingency table to find out the probabilities. What is the probability a salesperson selected at random will have above average sales ability and excellent potential for advancement? Construct a tree diagram showing all probabilities, conditional probabilities, and giant probabilities. So let us solve it. So we have answered part A. This is a table called contingency table. Now we are interested in solving part two. What is the probability a salesperson selected at random will have above average sales ability and excellent potential for advancement? So before starting this part B, better would be if we give some names to the events, okay? Because that will make it easy for us to handle the question. So see what I'm going to do with this question. So I'm going to write down this table again, sales ability. So sales ability, and I'm going to define the abilities below average, average, and above average as A1, A2, and A3. So this is what I'm going to write over here. A1, A2, A3, fine. And then there is a final row for total. So A1 means below average salesperson. A2 means average salesperson. A3 means above average salesperson. Now come to this row, fair, good, and excellent. Potential for advancement. So potential for advancement, you will write down over here sales ability, and then you write down over here potential for advancement. So I am not going to write down these two words. I am simply covering these events, fair, good, and excellent. So for fair, you may write down B1. For good, you may write down B2 or any alphabet that you like, you may give B3. So B3 is for excellent potential for advancement. And similarly, there will be total as the last column, like this. Right? So now let us write down these values 16, 12, 22. Then 45, 60, 45. 93, 72, 135. Is it? Let me check. 93, 72, and 135. Fine. Okay. So now you must have with you your calculator if you are interested in this class. Okay. So now you are required to add the values that are in rows. I mean 16 plus 12 plus 22. What is the answer? So quickly add and tell me.
50, sir, 50.
50.
Okay. A2, 45 plus 60 plus 45.
150, sir.
150.
A3, 93, 72, 135.
300.
300.
300. Now you are required to add the events that are written in columns. So 16 plus 45 plus 93. See what is the answer.
154.
154.
Yes, sir.
Fine. Next.
144.
144.
144. Next.
202.
202.
202. Okay, so now the answer should be 500. You can see over here, these trades for 500 sales people. So 500 should be there when you will add the values that are there in this last column, and when you will add the values that are there in this last row. So the answer should be 500. Please confirm it.
Yes, yes, 500, sir.
If it is 500, then you have
Yes.
added correctly. Otherwise, if it is not 500 from this side or from this side, then there will be some issue. So you have to confirm that these values, these three values are equal to 500, and these three values are also
Yes, 500, sir. Confirm, sir. But
confirmed. That's very good. That's very good. So now I have defined the events. Instead of writing, let's say, good, I have written B2. Instead of writing above average, I have written A3. So A3 means above average. B2 means good, like this. So now you could easily answer the question. What is the probability a salesperson selected at random? So you are going to select one person out of 500 people that are there in the pool. There are total 500 salesperson, and you are randomly selecting one person, or blindly selecting one person. So what is the probability that this person will have above average sales ability and excellent potential for advancement? So you have to see above average sales ability means A3, and excellent potential means B3. So A3, and this and is there. This and is there. So A3 and B3. What is the probability? Salesperson selected at random will have above average sales ability means A3, and means intersection, and excellent potential for advancement means B3. So you could answer this question as B. Answering part B, you could write this is the required probability: A3 intersection for and B3. So this is the required probability. So first of all, you write down this, right? And then you have to see that whether these events are dependent or independent, because whenever you see intersection, you move to the idea of dependency, and whenever you see union, you consider mutual exclusiveness of the events. So in this case, you have to see the dependent or independent, or dependency or independency of the events. So what is your opinion that whether these two events are dependent or independent?
Dependency.
Dependent, why?
Because of A3 is with B3 is the same.
Because the
So
reason is that at the same time, because at the same time, you could see A3, a person is there that is above average. He may be excellent. He may have excellent potential for advancement. Okay. So as he is above average, so excellent. As he is excellent, so therefore he is above average. So dependency is there. Excellence is basically a characteristic that is the reason for his ability of above average. Understand? And fair, let's say some person is fair. So as he is below good even, so therefore he has sales ability below average. Okay. Or otherwise, if you move from this side below average, the reason for his being below average is that because he has fair potential for advancement. So dependency is there. Okay. uh, so you could write down it as using the rules that we have studied in rules of multiplication in statistical theory. And we know that in the situations where events are dependent, we use general rule of multiplication, and that is A3, in this particular case, A3 intersection B3 is equal to probability of A3 multiply by probability of B3 given A3. Am I right?
yes, sir.
Fine. So now you have to find out the probability of A3 and probability of B3 given A3, and then you will multiply those two probabilities to have the answer. So let us see what is probability of A3. Probability of A3. So to find out the probability of A3, what will you do from contingency table? How will you calculate it from this table? I have solved an example in the previous class. Yes. What is the probability of A3? Quickly, we don't have time. A3, how many total people are there above average
Yeah.
in total? 300.
300, sir. Yes.
300 people are there that are above average. Okay. So this 300 and 300 from total. Total people are 500, including the other categories. So 300 divided by 500. 300 divided by 500. Fine. And then you are interested in finding out probability of B3 given A3. Probability of B3 given A3. So how will you find it out? B3
Good
given
way.
A3. Yes.
Excellent, sir. 135 divided by 300.
Yes, you will see that which value is there at the intersection point. So B3, 135, A3, 135. So this is the common point. This is the common value or intersection point. So 135 you will take. Okay, you will write. You will take this value 135. You will write down over here 135, and A3 is there. Given A3, so sum for A3 values you have to write down in the denominator. A3, what is the sum for A3? 300. So write down over here 300. Understand? This A3 is there. If B3 was there, then you have to add the values that are there in the B3 column, 202. But in this case, as A3 is there, given that A3, so you may write down the sum for A3, that is 300. Okay, so now you have this value and as well as this value. So you can simply multiply these two values. So when you will multiply, see what is the answer. Answering this part B, probability of A3 intersection B3, A3 intersection B3. So you could see it is equal to 300 divided by 500
0.6.
multiply by 135 divided by 300. So this 300 will be cancelled out, and you will remain with 135 divided by 500. See what is the answer.
0.27.
0.27. So this is the required probability. So you could say that 27% are the chances that a randomly selected salesperson will be a person with an above average uh, ability of sale, and at the same time he would have excellent potential for advancement in his career. Understand? So in this way, you will answer part B. Construct a tree diagram showing all probabilities, conditional probabilities and giant probabilities. So all probabilities, conditional and giant. So how will you draw this table? This is the question that we have to answer today, because this is the new topic, tree diagram. So you may start from a stem. Let's say this is the stem. Okay. So now you may move from any direction. You may move, you may take, let's say in this case, uh, there are three events, A1, A2, A3, and there are three events, B1, B2, and B3. Okay. So let's say there were two events, A1 and A2. The third event was not there. Then you better if you start from A, because if you see there's one stem or two stems and then there are branches. So branches are more than the stem. Fine. But in this case, as equal events are there, so you may take three stems, okay, and then further onward the branches. So you may take stems as B1, B2, B3, or A1, A2. So let us solve both situations. So first I'm going to take the stems, three stems as, let's say this is the situation. And these are the, let's say, three stems. Okay. So the first stem is A1, or you may write down over here below average, average, and above average. So below average you may write down over here instead of A1. But better would be if you write down A1. If you are answering the question on manually on your answer booklet. But in that case, you must have to define events first. Otherwise, the examiner will remain unable to know that what is A1. Okay, so it's upon you that how you handle the question. So A1, A2, and A3. In this way, you may write down. Now, what is the probability for A1? So here you may write down probability for A1. Probability for A1 is equal to what? Similarly, probability for A2 equal to what value? Similarly, here you could write down probability for A3. What is this probability? So for this, you have to see the sum of the rows because A's are written in the rows. So A1, you have to see this value. A1, the sum is 50. A2, the sum is 150. A3, the sum is 300. So 50, 150, and 300. 50, 150, and 300. Like this. And as you are going to select these people from a pool of 500, so divide each value with 500. 150 divided by 500. And similarly, here 300 divided by 500, like this. Right? And onward, if you move, there are conditional probabilities. So conditional probabilities that how will you write down those probabilities? For that, there are three possibilities. Let's say for A1, again, you will drag branches from A1. There will be three branches. There will be three branches, and there are two possibilities. And the person is, let's say, if you see this, the person is below average, and he has fair potential for advancement. Another possibility is that he is below average, but he has good ability for advancement. There is another third possibility. The person is below average, but even then he has excellent potential for advancement in the future. So B1, B2, and B3, these three are the probabilities or events, you say, that you have to write down over here. B1, B2, and B3. Fine. Similarly, there are three branches, or there will be three branches with A2. So those again will be, B1, B1, B2, and B3, like this. Then move onward and have branches for A3. There are three possibilities: B1, B2, and B3. Fine. So let me have the page in. Landscape, I want to have it, but before that I have to break the page. Landscape. Yes, now it is easy for me to cover it. Okay. So now what will you write down over here? Initially, if you see A1 was there and you were interested in finding out the probability of A1. Now you are interested in finding out the probability of for B1, given that A1 has occurred. Okay. So how will you write it down? You will write it down as probability of, let me write down, probability of B1, B1 uh, given A1, probability of B1 given A1. Similarly, over here you write down probability of B2 given A1. Okay. Similarly, here you write down probability of B3 given B3, sorry, B3, B3 given A1. It is A1, not A2. This is A1. Like this. Close the braces. Similarly, for A2, how will you write it down? Probability of B1 given A2. Similarly, probability of B2 given A2. Here you write down probability of B3 given A2, like this. And finally, probability of B1 given A3. Can you understand? Although I'm writing with my finger, but I don't know whether you are able to see this or not. I think it is visible. Probability of B2 given A3. Probability of B3 given A3. In this way, you will write down the probabilities. Now see, these are the probabilities, simple probabilities, or you may also call these probabilities as prior probabilities. And these are the probabilities that we call the conditional probabilities. And finally, there are giant probabilities. Here you will give the title as giant probabilities. Giant probabilities. Like this. Because if you see the question, these three are required. Show all probabilities, conditional probabilities, and giant probabilities. So all probabilities are these probabilities: A1, A2, and A3. These are the conditional probabilities, and finally we will write down the giant probabilities. So what are the giant probabilities? So giant probabilities are basically the multiple of this value and this value. So as I don't have space over here and I don't want to make the tree complex, so I'm not going to write down the value over here, but I will write down the value over here. The first value will be probability of A1 multiplied by probability of B1 given A1, like this. So this will equal, probability of A1 is 50 by 500 multiplied by B1 given A1. B1 given A1. So you have to see the intersection point and then you have to write down the sum for A1. So intersection point B1 A1. B1 A1. B1 A1 16 and sum for A1 is 50. So 16 divided by 50. The other will be, let us see, let us first write down this. 16 divided by 50. 50. And when you will multiply these two, 50 will be cancelled out with 50 and you will remain with 16 divided by 500. Understand? Fine. Then see the next value. Probability of A1 multiplied by probability of B2 given A1. So now A1 we have already found 50 divided by 500 multiplied by B2 A1. So B2 and A1. B2, A1, 12 divided by 50. 12 divided by 50. So 50 will be cancelled out with 50 and you will remain with 12 divided by 500. Understand? At least you may say yes so that I may know that you are connected with me.
Yes, sir. Yes.
Fine. Okay. Then for the third situation, probability of A1, probability of B3 given A1. So again 50 divided by 500 divided, 50 divided by 500 and you have to multiply this with B3A1. B3A1, B3A1, 22. 22 divided by 50. 22 divided by 50. 50, 50 cancelled, and you will remain with 22 divided by 500. Okay. Similarly, for this, you will multiply A2 with B1A2. So B1A2 will be B1A2, B1A2, 45. So A2, so sum for A2 is 150. So 45 divided by 150. 45 divided by 150. And if you see this, 150 is there in the numerator. So 150 will be cancelled out with 150 and you will remain with 45. Understand?
Yes,
As
sir.
we have done over here.
Yes, sir.
As we have done over here. So therefore, I am going to write down these probabilities straightforwardly. 45, 60, 45. Let me change the color. So the first probability will be 45 divided by 500. Second will be 60 divided by 500. Third will be 45 divided by 500. I think it is clear.
Yes, sir. Yes, sir.
Okay. And then in third case, B1A3. So B1A3, B1, B1A3, 93, 72, and 135. 93, 72, and 135. So you would write down these probabilities in this way. You would also write down these notations, probability of A2 and then probability of B1, A2 like this. So you would have to write down these things over here. Then you will multiply. Then finally you will write down this column, this column that I have written over here. So, but I have skipped these two for the remaining two cases. I have simply written these values that I would have in the other two situations. So now you can see the answer will become equal to 100% probability. So you can simply add the value 16 plus 12 plus 22 plus 45 plus 60 plus 45 plus 93 plus 72 plus 135. All will equal 500 divided by 500. The answer will become equal to 1. So this is tree diagram. Fine. Is it?
Yes, sir. Fine, sir.
Fine. So now this is one way of sketching the tree diagram. The other way is that you may start the tree, because in this case, if you see, three events are there in the rows and the columns. Okay, so you may start from B1. You may write down B1, B2, B3 as three stems. So let us do it that way. No problem. There are three stems. Three stems. In fact, I should have some more space so that it become easy for me to handle things. Okay, so let us see what happens. This will become B1, B2, sorry, B2, and finally B3. Okay, so probability. So you may write down over here probabilities with these events, probabilities and probability of B3. Okay, here you may write down fair, good, and excellent. Or otherwise, you may write down B1, B2, and B3. It's upon you. Okay, what you write. Then from fair, there are again three possibilities. So let me change the color. There are three possibilities. What are those three? Those are A1. Instead of writing A1, A2, A3 over here, you may write down here as I am using fair, good, and excellent. So here you may write down below average, below average, below average, average, and above average, like this. Or you may write down A1, A2, A3. Fine. And then here you write down probability of below average is A1. So A1 given B1. Similarly, probability of A2 given, sorry, probability of A2 given B1. Okay. So here you may write down, if you are confused in this, you may write down B1, B2, B3 over here. I think you are not confused. You can handle it. You may write down over here B1, B2, and B3, or you may write down fair, good, and excellent. So it's upon you. Similarly, you may write down over here A1, A2, and A3. So what should I write?
As previous, sir, is better. A1, A2,
Is
A3.
it fine, or should I change it BA with A1 and
Yeah,
like that?
it's fine, sir. It's fine. So we can have it.
Fine. Okay. So A2 and B1, and then finally you would have probability of A3 given B1. Right. And similarly, you could write down the probabilities over here. Three possibilities will be there. The first possibility will be probability of, let me change the color, probability of A1 given B2, because if you see B2 is here, you are taking into account this term. So in this term B2 has already occurred. So A1 given B2, A1 is here, A2 is here, and A3 is here. So below average, average, and above average. Here probability of A2 given B2. Similarly, probability of A3 given B2. And similarly in this case, excellent. So excellent. So let me draw the branches over here as I don't have space. So A1, why it is like this? It should be okay, no problem. A1, A2, A3. So what will be written over here? Probability of A1, A1 given B3, this value B3. Similarly, probability of A2 given B3. Finally, A3 given B3, like this. You will draw the tree diagram. So when you will draw it on your page, there will be sufficient space, and you will write it down fairly. Fine. So now, as I have multiplied the probabilities, the initial probabilities or the prior probabilities and the conditional probabilities to have the giant probability, so you can simply find out the values and you may multiply. So 50, 150, and 500. In this case, and what will be the value in this case? Probability of B1, probability of B1, B2, B3. So probability of B1 you can see from here, B1. What is the sum for this? 154. Total 500. So 154 divided by 500. B2 144 divided by 500. B3 202 divided by 500. So 154, 144, and 202. 54. What was the second?
144, sir.
144. And what was the third one?
202.
202.
202. So divide by 500, divide by 500, and divide by 500 like this. And then you will find out these probabilities A1 and given B1. So A1 given B1. What is the probability for A1? We have to see the intersection point A1, B1, where these two meet. A1, B1. 16. Okay. 16. And then you could see B1 is there. B1. So sum for B1 we have to write down. Sum for B1 is this value 154. So what will you write down? 16 divided by 154. 16 divided by 154. So this value is 16 divided by 154. This value will become equal to A to B1. A to B1 45. So 45 divided by 154, and then 93 divided by 154. 45, 93. Sorry, 93 divided by 154. Understand? In this way. Now you could see when you will multiply these two, 154 will be cancelled out with this 154, and you will remain with 16 by 500, 45 by 500, and 93 by 500. So that is what we call the giant probability. So it will be 16. So you will write down over here giant probabilities completely. You write down, and then 16 by 500. Then 45 by 500. You will properly multiply. I'm just doing it verbally. Because I am not working on the whiteboard. So therefore, there is a problem. Similarly, in this case, what will be the situation? 144, 202, and 154. Okay, so 144, the second case is there, 144. This is 144. Okay, so this 144 will be cancelled out with 154, and you will remain with these values 12, 60, 72. 12, 60, 72. 12, 60, 72 divided by 500 divided by 500 divided by 500. And finally, A1, B3. So A1 and B3, A1, B3. Fine. So 22 will be there, and B3, 202 total. So 22, 45, 135, because 202 will be cancelled out with the numerator. So 22, 45, 135. All divided by 500. So you will neatly write down these figures. Sorry, I am unable to write down these values fairly. Okay. So now when you will add these values 135, 45, 22, 72, 60, 12, 93, 45, 16, the answer will become equal to 1. So I mean, you may adopt any route, no problem. So this is what we call tree diagram. In tree diagram, all possible probabilities are covered. Now you may solve the other questions that are there in this exercise, and you feel any problem in solving these questions. This is your activity that you have to do today or tomorrow. And if you feel any problem, you may ask in the next class. Okay. Then there comes Bayes theorem. And there comes Bayes theorem that we have to cover. What is this Bayes theorem? In the 18th century, Reverend Thomas Bayes, an English Presbyterian minister, this is some area, pondered this question: does God really exist? Okay, so this was a question that arose in his mind. Does God exist? Being interested in mathematics, he was a good mathematician. He attempted to develop a formula to arrive at the probability God does exist based on evidence available to him on earth. So based on the evidences, that there are so many evidences available on the earth that are, uh, you can say, proof of the existence of God or Allah Almighty. Okay, so he was just thinking about that there are so many things on earth available. So can we use those to have the confirmation regarding existence of God? You can say empirically. So he tried this, but unfortunately he died and he remained unable to prove this. Because there may be a reason that there are so many available evidences that may help in understanding that there is some power, there is some God, and definitely that is only one God. Because if more than one gods are there, then there will be no, you can say, there will be conflict in things. Okay, so there is only one God that is controlling each and everything in the universe. Okay, and he is basically the creator of that universe, but he remained unable to prove it empirically. But later on, when he died, later on, from his notes, later Perry Simon Laplace refined Bayes' work and gave it the name Bayes' theorem. So basically, his friend Richard Price was there, who was just looking his notes, and he found this formula in his notes. Richard Price, this was the person, was basically one of his friends, Bayes' friend, Richard Price, whose name is not there in this explanation. And he found this formula, and then he published an essay. That the title for that essay was, I think, an essay towards solving a problem in the doctrine of chances. So that was the essay that he first wrote, and then this person came later on, Perry Simon Laplace, refined the Bayes work. So he refined the Bayes work, and finally he provided this refined formula, and he gave this formula the name of Bayes. So now we know that this formula is Bayes theorem or Bayes formula. So this is the Bayes formula that may help us in utilizing the most recent information to say something about the some future event. Okay, so let us see different questions that may help us in understanding that what we mean by this recent information and how we would utilize that recent information uh, using this formula to have some good idea of occurrence of some future event. So there are different questions in your book. You may see different questions, but I am interested in solving a question that may help you understanding the concept clearly. Okay, come to next page. Okay, so let me write down a question for you. I have devised two questions for you. Let's say this is an example. Let me hold. Okay. Example. Let's say me. Let's say me knows that 75% of my students, 75% of my students means his students submit their assignments. Okay, let's say I know that 75% of my students submit their assignments. He also knows that, sorry, also knows that out of those 75%, or you may write down out of those who submit the assignment. So it is understood that those are 75%. Pass the course, let's say this course, or the statistics course, or simply you may write down pass the examination. It's upon you. You may write down maybe any situation. Pass the examination or pass the course. Now see the statement. Whereas, so remember that this formula is very important, and we almost use in all fields this formula to have some better information that we could not have if we are not using this formula, because this formula utilizes the most recent information and provides the good result. So whereas among those, who do not submit the assignments, definitely there are some students who are submitting the assignments, and there are some students who are not submitting the assignments. So let's say among those who do not submit the assignments, 65% pass the examination. So definitely who don't submit the assignments, out of those students also some students will pass the examination. It is of common sense. So let's say Mr. Hasnath passed, announced, it has been announced yesterday that Mr. Hasnath passed. Hasnath passed yesterday. This is an announcement. Oh, what is the probability that he had submitted the assignment? Okay. So now this is the latest information. Normally, what happens? Normally, this happens that 75% of the students who submit the assignments, they normally pass the examination, and out of the remaining 25%, 65% pass the examination. This is the normal, you can say, scenario. And what has happened yesterday? Mr. Hasnath passed the course. So the question is whether he had submitted the assignment or not. So you have to find out the probability that he had submitted the assignment. He had submitted the assignment. So this may be the one situation. This may be the one, you can say, question. And I may change the question also. Let me change the question on, let's say, after 2 pages. Let us change the question over here. Sorry. Now, let's say example takes this shape. This is the example. Can you hear me?
Yes, sir. Yes, sir.
You should be with me. Okay. Now I'm writing down another scenario. Then I shall solve both. Now, see, Dr. Saif knows that, let's say, 90% of students pass the examination or statistics course. Now you can see what has happened. Now I'm saying that he knows that 90% of his students pass the examination. Here, what I was saying, that he knows that 75% of his students submit their assignments. So now I'm saying that he knows that 90% pass the examination. Here I know 75% submit the assignment. So scenario is different. Okay. So accordingly, we shall answer the question. Out of uh, those, 90%, or you can say out of the students who pass the examination, out of those students who pass the examination, definitely those are 90%. Let's say 80%, submit the assignments. Okay, so those 90%, out of those 90% who pass the examination, 80% out of those 90% submit the assignments. This is the scenario. Now see, whereas among those who fail the examination, 40% submit the, or you can say 40% submitted the assignments. So you may know that it is quite possible that people who are failing the examination, they had submitted the assignment. So they submitted the assignment, but even then they failed the course. It is quite possible. It is of common sense. So now see the scenario. What is the scenario? The scenario is this: Mr. Let's say, let me have some other name. Let's say Kashif Amin. So Kashif, let's say Kashif, Mr. Kashif submitted the assignment. So Kashif submitted the assignment. So now the question is, what is the probability? What is the probability that he passed the examination. So there may be a question that what is the probability that he failed the examination? So any question may be there. So let us solve these two situations. Okay. So what is the probability that he passed the examination? And in this case, what is the probability that Mr. Hasnath submitted the assignment? So now, first of all, you will write down the probabilities utilizing the names of the events that you will give to different events. So let's say, I'm going to say that let uh, SUB, probability of submitting the assignment is let SUB be the probability that students submit the assignment. So you may write down first let, I'm not going to write down that. I'm simply using that. But you will write down first let SUB is the probability that student will, let SUB be the event that Mr. Hasnath will pass the examination. Okay, so what will be the probability in that case? Probability of submission SUB. Let's say I'm going to write it down as this. So this means Mr. Asnath, or let's say not Asnath, submission, the probability of submitting the assignment. What is this? This is given 75%. Okay. So 75% means 0.75. 75% people submit the assignment. 75% people, this people is for students. Okay. 75% of people submitting the assignment. I have extracted this information from this sentence. Now he also knows. So before writing that, before moving onward, if 75% are submitting, what percentage of students are not submitting the assignment? Yes.
0.2.
25%. Simple. So if you are going to write down SUB for submission, you may write down NSUB. This will means not submitting the assignment. Or you may write down A, B, C, whatever event you want to define, you may define. But I have defined it as let N sub be the event that students not submitted the assignment. Understand? So if submission is 75%, so non-submission will be 25%. Simple. Is it or not? Complement rule. Yes. Submission plus non-submission will equal 100% or 1. So if 1 is given, I mean 75% submission, then the remaining will be 1 minus 75%. So that will be 25% or 0.25. Understand? So you have to write down the given information in this way. Now see, he also knows that out of those who submit the assignment, out of those who submit the assignments, how many pass the examination? So that I have to write down over here. What percentage pass the examination? Let's say 91%. Let's say 91%. 91% pass the examination. 91% pass the examination. Out of whom? Who submit the assignments. So let us see how will we write down this event. You will write down probability. Probability given that. Okay. What is given? Out of what? Out of those who submit. Out of those who submit. So you will write down this submit over here as given. And probability of what? This 91% pass the examination. So pass the examination. So you may write down pass the examination. So let pass, or you write down pass, or you may write down PA, or whatever you want to write, you may write down. So probability that the students who submitted the assignment, out of those who submitted the assignment, what percentage passed the examination? 91%. So 0.91. Understand? Right. And then move onward. Whereas among those who do not submit the assignment, who do not submit the assignment means now you will write down probability of not submit the assignment. Out of this, 65% pass the examination. 65% pass the examination. Pass, and 65% means 0.65. Right. So this is what you have in the question. Now, see what is the question. Mr. Hasnath passed yesterday. Mr. Hasnath passed yesterday. So probability. What is given? Pass. Somebody or Mr. Hasnath has passed the examination. What is required? That will be written over here. What is the probability that he had submitted the assignment? That he had submitted the assignment. So SUB will be written over here. This is the required probability. Can you understand? Sub is there and pass is there. Okay. Now come to the next question. See this question. Write down the given information. Now, Mr. Saif knows that 90% of his students pass the examination. So probability of pass. What is the probability of pass? 90%. Okay, and definitely the probability for fail or not pass.
10.
Definitely not pass means fail.
10%.
Sorry, fail. What is the probability for fail? So I have defined the event. Let fail be the event that he failed the examination, or you may write down let F be the event that he failed the examination. So I am writing down fail. You may write down F. So whatever you will define, you will use that. So definitely pass plus fail will equal 100% students. Students are there 100%. So if 50% are passing the examination, then 50% will be failed. So in this case, if 90% are passing the examination, so 10% will fail the examination. So complement rule. Understand?
Yes, sir.
Yes, sir.
Ji, sir.
Fine. Now see the situation. Out of those who pass the examination, means now you will write down, as you read the sentence, you will write down over here pass. Out of those who pass the examination, you will write down like this. And what you will have to write down over here, see the statement. Those students who pass the examination, 80% submit the assignments. 80% submit the assignment. So 80% 0.80, and here you will write down submit. Fine. Next. Whereas among those who fail the examination, 40% submitted the assignment. Among those who fail the examination, means fail out of failed students or not, who did not pass the examination, 40% submitted the assignment. Submitted 40%. So I have converted the story into probabilities. Understand? Mr. Kashif submitted the assignment. Mr. Kashif submitted the assignment. This is the information that we have. He has submitted the assignment. Now, what is required? What is the probability? That will be written over here. What is the probability that he passed the examination? He passed the examination. He passed. Sorry. Pass the examination. This is the required probability. So now you can compare it. Pass, submission. What is the probability that he is gonna pass the examination, and it is confirmed that he had submitted the assignment. So submission is there. And if you see this situation, submission is there, given that he passed the examination. So scenario has changed. So now how will you use the uh, Bayes formula or Bayes theorem to find out this probability? So if you see the Bayes formula, this is the Bayes formula. This is the Bayes formula. AI given B. So you can simply repeat the terms. AI given B. AI is there. BI given AI. So then you will write down this term again in the numerator if there are only two events. If there are three or four or five events, then the new denominator will be there with an extended form. But here only two events are there. So this term will be repeated, and here as I is there, so A2 will be there. So I shall prove this formula if I would have time today, that how this formula will be there. But let us use this formula first, and then we shall move to the proof of this formula later on. I shall try to prove it today, inshallah. So summation and pass. So this is the required probability, and using the Bayes theorem, how could we write it? This is equal to, this term is equal to, now you have to repeat this term, probability of submission multiply by probability of pass given he had submitted the assignment. And then repeat this, whatever you have written over here, probability of submission multiply by probability of pass given submission and plus. Now you have to write down the other event. And what will be the other event? The other event is that, or possibility is that he definitely here, if you are using submission, then here you will use not submission, non-submission. So let me write down the probability that student did not submit the assignment, right? And probability that he passed the examination, given that not submitted. So here you can see submission, pass, submission is there. No submission, but even then pass. So here, given that no submission was there. Assignment not submitted, pass the examination. Assignment submitted, yes, submitted, and pass the examination. So now you could simply substitute the values that we have already written over here in the formula, and this will give us the answer that the randomly selected student, that was Mr. Hasnath, he had submitted the assignment, and what are the chances for that. So what is the this value submission? Let me, sorry, even then it will remain not visible. So I request your help. Give me the figures. 0.75 multiply by pass submission 91%, 0.91 divided by submission. So same value will be there, 0.75 multiply by 0.91 plus not submission 25%. I mean 0.25. Let me correct it. 0.25 multiply by pass not submission 0.65. So now what is the multiple of these two terms? 0.75 multiplied by 0.91. Quickly do it. 0.6825, is it?
Yes, sir.
And then multiply these two terms. So this term will be same, 0.6825. and calculate for the other term. 0.25 multiplied by 0.65.
0.1625.
0.1625. Now add these two terms that are there in the denominator and solve it. The answer is
Denominator is 0.845.
no. First add these two values and then divide. 0.6825 divided by, first of all, find out the
Point
sum for these two terms. 0.6825.
0.845, sir.
Sorry?
The sum is
0.845.
0.845.
Let me see. Let me see. 0.6825 plus 0.1625. The answer is 0.845. The answer is 0.8450. Okay, so now divide it.
0.807692.
0.80769. So the answer is point, when you will round it off up to 4 decimal points, you will have 0.8077.
769. Oops.
0.8077.
7.
So you can say that 80.77% are the chances that Mr. Hasnath, who passed the examination, had submitted the assignment. Good chances. Good chances. Fine.
Yes.
Now come to the other scenario, and there are so many scenarios that are there in your book. You are suggested to solve all those questions. Okay, and if you feel any problem, you may ask me, but the strategy will be same. You will extract the information from the given story, and you will give that statement this form, probability form, notations form, right? So now this is required, and when you will see this, how the formula will take the shape. So this will equal probability of, first of all, write down pass, multiply this with summation, write down summation, and now given that pass, write down the formula in this way. Then in the denominator, repeat the term that you have written in the numerator, pass, multiply by summation and pass. Now see what is the other probability, other possibility against pass, that is fail. So write down over here probability of fail. This is the other possibility, fail, and multiply this with probability of summation. This will remain same, summation, but this will change. When pass, then fail, given fail. Understand? So now you will have all the values that you already have. Basically, you have found. So write down those values. So pass, the probability of pass is 0.90, multiply by summation pass 80%, 0.80, repeat this term, 0.90, multiply by 0.80, and plus fail. So fail 10%, 10% fail, and summation fail,
Point,
40%.
point,
40%. So multiply these terms and have the answer. See what is the answer. 0.90 multiply by 0.8, 0.72 divided by 0.72 plus 0.1 multiplied by 0.4, 0.04 plus 0.72, 0.76 multiplied by 0.72 It is 0.9474. 74. 0.9474 or 94.74% are the chances that Mr. Kashif, who submitted the assignment, have passed the examination. Understand? Clear?
Yes, sir.
Yes, sir. Yes, sir.
Okay. So now let us make another situation. Let us make another situation from here. I'm going to change the question. Let me change the. I may change over here the last statement. I may write down it as what is the probability that he had not submitted the assignment. What I'm going to do, instead of writing submission, I'm saying not submission, no submission, not submitted. Okay, then scenario will entirely change. The scenario will change. Similarly, it's upon you. You may write down over here not, and you may try for that. But for your convenience, I'm going to write down this word not over here. What is the probability that he did not pass the examination? Now the question is, what is the probability that, okay, let me copy it down. What is the probability that he did not pass the examination? So now this is the situation. So can you solve it? If you are able to solve it, then you can solve the other scenario that we solved first. So let us first write down the information, or you can write down over here given information. What is given? 90% students pass the examination. So probability pass 90%. Fine. So probability for fail will be 10%. Simple complement rule. Understand? Next, out of those who pass the examination, out of those who pass the examination, out of, so pass, out of those who pass the examination. Now be attentive. Out of those who pass examination, 80% submit the assignments. Submission is there, and pass is there. 80% is the answer. Submission, pass. What will be the other scenario? What will be the other scenario in this particular case?
Unsubmit, sir. Not submit.
Sorry,
Not submit.
so I'm unable to hear you.
Oh, I might. Okay.
Submission is there and pass. The other scenario is not submitted and pass. What is the other scenario? Not submitted and pass. The other scenario is not submitted and pass. If you see this, submitted and pass, submitted and fail. So let us see over here. What will be the probability that, let me write it down in red. Probability not submitted, pass. So if you use the complement rule, then what will be the probability? 80% are the students who submitted the assignment given that they passed the examination. So if I ask you what is the probability that they did not submit the assignment but they passed examination. So in total 1, and
Yes.
1 minus 80%, the answer will be 20%.
70%.
And if I ask you here, what is the probability that he did not submit the assignment and he failed the examination? So fail the examination
60%.
1 minus 40%. So this will be
0.
60.60. So these two are the values that you will need in the question that I have asked over here. Oh, where is that question? Yes, this question. Okay, so now let us write down the problem. What is the probability that he did not pass examination, and what is given? Submitted the assignment. He submitted the assignment. This is given. So write down over here, submitted assignment. And required probability is that he did not pass the examination, means he failed the examination. Fail. Submitted but fail. So you have to write down this, and this is the required probability. So now taking help of Bayes theorem, Bayes formula, what is the numerator in this case? Probability of fail. Probability of fail multiplied by probability of submission. Fail. Fine. And repeat this. Probability of fail and multiply by probability of submission. Fail. And what is the other scenario, other possibility? Other possibility is that probability of, if you see fail, and if you see this situation, what I have written over here, pass, fail, pass, fail, submission, submission. So pass, fail. So here, what will you write down? Fail, pass, and multiply by submission and pass. Understand? So now you will give the values. So you fail, fail, pass, pass. In both cases, he had submitted, because we are confirmed that he had submitted the assignment. So therefore, submission is there. Submission is there. Submission is there. In this case, if you see, again, submission is there. So if I change the question that he did not submit the assignment, let's say I am going to change over here the statement, Mr. Kashif did not submit the assignment, then non-submission will be there. At this position, at this point, non-submission, here non-submission, and again here non-submission. So everywhere you will find non-submission in that case. So examiner may change the question. So therefore you have to handle the question accordingly. Fail. What is the probability of fail? I found over here 0.1 multiply by submission and fail. Submission and fail. Submission, fail, 40%. Fine. In the denominator, you will repeat this term because first term is same, 0.40 plus. Now, probability of pass. What is the probability of pass? 90%. And submission, given pass, submission, given pass, written over here, 80%. Solve it. See the answer. Point 0.04 divided by 0.04 plus 0.9 multiplied by 0.8. 0.72. See what is the answer. Plus 0.04 minus multiplied by 0.04. I have found it as 0.0526, or you may say 5.26% are the chances that Mr. Kashev, who submitted the assignment, did not pass the examination. Okay, understand or not
Yes,
understand?
sir. Yes, sir.
Yes, sir. Yes, sir. Got
So
it.
it is not that difficult. You just have to be attentive to solve such questions. Okay, so now try other scenarios that are given in your book, or you may change these scenarios as I have explained, that you may take the situation where you may write down here Mr. Kashif not submitted the assignment, okay, did not pass the examination, or submitted the assignment, passed the examination, submitted the assignment, did not pass the examination. Similarly, in this case, you may write down over here in this situation, Mr. Hasnath did not pass the examination yesterday. Mr. Hasnath failed the examination yesterday, and the probability that he had submitted the assignment or he had not submitted the assignment. So, in different cases, you may use the Bayes formula. So, now let us try proving the Bayes formula, and this is the final topic that I want to cover today. Basically, I was interested in explaining the rules of you can say the counting principles, basically, in which we talk about multiplication formula, the permutation formula, the combination formula. But I don't think that I would have time to cover that today. But let me try proving the Bayes formula. Okay, so let me cover it. So I want to make it easy for you so that you can easily prove this. Okay, I don't find the relevant page, but let us try. Let us try solving this. Uh, let's say there are two events. One event is AI and the other event is B. So first of all, try considering this. Then I shall write down the statement. If I write down probability of AI intersection B, okay, equal to probability of B intersection AI. Is it true? Is it true or not? Use your common sense.
Yes,
Yes,
sir.
sir.
It could be, sir.
Yes, it is true. Why? Because if I say Hasnath and Kashif, Hasnath and Kashif,
Okay.
or otherwise I may say Kashif and Hasnath, both are there in the class. Okay. So it doesn't matter that whether I am uttering the word Kashif first or the word Hasnath first. Both are there in the class. So these two events are equal. Okay. AI intersection B is equal to B intersection AI, or A intersection B is equal to B intersection A. No problem. Equal. So if these two are equal, and general rule of multiplication you are going to apply over here, and you say that the events are dependent, then if you open the left hand side, what will be the answer? Probability of AI multiplied by probability of B given AI. Is it? General rule of multiplication. And here in this case, on the
Yes.
right hand side, probability of B multiplied by probability of AI given B. Fine. Now, in the base formula, if you see AI over B is there. In the base formula, if you see AI over B is there. Is it or not? Yes, it is. So if I solve this example, this equation for AI over B, how could I write it? Probability of AI given B will equal this left hand side, probability of AI multiplied by probability of B given AI. B given AI, and you are going to take this probability of B to the denominator, cross multiplication. Take this side to the denominator of this term. So this will be probability of B. This will be the probability of B. So basically the formula is, if you see the formula for Bayes theorem, that formula is, if you see in simple terms, it is probability of AI divided by B is equal to simply this term, probability of AI, probability of B given AI, as I have written over here. You can see this same. And instead of writing probability of B, what I'm going to write down? I'm going to write down this term, summation I from 1 to K, I from 1 to K. And here I'm going to write down probability of AI. I'm simply writing down the term that is written over there in the numerator, probability of B given AI. Okay, so this is the formula. So this term and the term that is there in these two terms that are there in the numerator, these two are same. This term and this term, these two are same over here. You can see this term and this term. Only probability of B we have to prove equal to this term. Once we prove that probability of B is equal to this term, then it means that we have proved the Bayes formula. Fine. So let us see how would we prove this. Let us see how would we prove this. So for that I'm going to solve. I'm going to write down things over here. These things you will write down first, and then you will write down, first of all you write down this formula, and then you will write down over here the statement, or otherwise let me correct it. Let me have my cursor down. There's a problem. Okay, I want to basically type it. So let me type it here on next page. Let's say if events AI means A1, A2, A3 and so on up to AK form, let's say they form a partition. They form a partition. I will draw the diagram, Venn diagram, that will further help you in understanding the concept. But let me complete first. Let me make it big, slightly bigger. So AK, and remember that this is a subscript. Let A1, A2 up to AK, these are the events from a partition, from a partition of a sample space, sample space S. That is the events AI. You know AI I am using for I is equal to 1 from 1 to 3 up to K. So instead of writing A1, A2, AK, I am writing down it as AI. The events AI, and I is here again the subscript are mutually exclusive, are mutually exclusive, and their union is S. Their union is S. Fine. And B, and let's say this is the information regarding A, that let me draw the diagram simultaneously so you may understand the story that I basically want to explain over here.
सर काफी है सर.
Okay, so this is what I want to write over there. Let's say this is the sample space S, okay, and AI means A1, A2, A3, so on up to AK. These are the events that are partitioning the sample space, that are partitioning the or dividing the sample space. This is what I have written over here. Events A1, A2, AK from a partition of a sample space S. That is the event AI. Events AI are mutually exclusive. They are mutually exclusive means they could not occur at the same time. And their union is S. And B, and let's say B is any other event, is any other event. If I leave it here, then it will remain. And basically, this is not there in your book. So you will remain unable to find it out from your book. So therefore, as you know, we also have time. So basically, the time is over. I know it is from the class is from 2 to 3:30 basically. So I have taken 25 minutes more. But normally we waste 10 minutes initially when we start the lecture. So please don't bother. Just try to learn things. I'm just concluding this. So if I take a few more minutes, I think there shouldn't be any problem. May I take?
Yes, sir. Let's proceed, sir.
Okay. And B is any other event. If somebody is not interested, so I may leave it over here at this point. But you know, this
No,
is
sir.
the recorded lecture. So later on, when you will open the recording, you will not this there. You will not find this in the recording. If I will leave it over here.
No, sir. Please go on, sir. Complete this topic, sir.
कंटिन्यू रखें सर.
Should I complete it?
Yes.
कंटिन्यू
Yes,
रखें
sir.
सर.
Yes, sir.
Okay, fine. And let B is another event. Let B is another event of sample space S, of sample space S, such that such that it can occur, such that it can occur only if one of the AI, one of the AI occurs, one of the AI occurs. Then for any I, then for any I, then for this is small I, make it bold. Then for any I, this is the formula. Then for any I, this is the formula. AI given B. So you will write down that, sorry, this formula, this formula, this formula. So you will start answering if proof is required. You will start writing down from this point, if events so on up to this point. Then for any I, and then you will write down this formula. And then you would try proving this using this strategy. After writing on that formula, you will start from this point. So if you only remember this, that AI intersection B, B intersection AI, this is the point from where you have to start proving the formula. So you may write down these two terms. So, but these two terms will be written after this statement. This statement will be there first, and then any I, and then you will come over here. At this point, you will write down this formula. Then you will write down this step and move onward. So let me first explain that what I up to this point, you have the idea that what I mean. A1, A2 up to AK, these are the events that are there in this sample space. In this sample space, these events are making partition of the sample space. Fine. These partitions are, let's say this area is covered by event A, this area is covered by event B, A3A up to AK. And when you will add all these events, and remember that events are mutually exclusive, so you will simply add. When you will simply add all these events, you will have S, the sample space. Okay, it is clear. And B is an other event of sample space S, of sample space S, such that it can occur only if one of the AI occurs. So I mean B is an other event, and let's say this is the event like this. This is the event that I call B. Okay, so now you can see that only if if A1 is there, the B will occur, the B will be there. So A1 intersection B, basically AI intersection B is there in the formula. So A1 intersection B, A2 intersection B, A3 intersection B, AK intersection B. So at least one event will be there to have B. And B is an event of the sample space S, such that it can occur only if one of AIs occur. So if one of AI, I mean A1 or A2 or up to AK, if only one occurs, then B will be there and B will occur. Right? It can occur only if one of AI occurs. One of AI means there are so many AIs up to AK. So if only one will occur, this event is there such that there is some commonality, because some portion of A2 is being covered by B, and that is this portion. So there will be some common thing between A2 and AB, similarly between A1 and B, similarly from AK, and so between AI and B there is something common, AI intersection B. This is what we have written over here, AI intersection B, AI intersection B. Understand? So I means all A1, A2, A3 up to AK. So some portion is common that is there in the sample space. Fine. So now if we prove that probability of B is equal to this probability of B is equal to this denominator, then we would be proving the formula, the base formula. So now our mission is to provide to prove that probability of B is equal to this. We are interested in proving probability of B is equal to this. Once it is equal to this, then we will simply write down, instead of writing down over here B, we will write down that we have to prove. Understand?
Yes, sir. Yes, sir.
Yes. So you may
Yes.
say yes so that I may know that you are able to understand. So now for that, what we have to do, we will write down over here. Uh, if I write down over here, B is equal to uh, S intersection B. B is equal to S intersection B. Can I write down? Where is that? No, better would be if I write it down over here. If I write down B is equal to S intersection B. Can I write down? Yes, I write down. Whatever is common between these two, that is B. The common between S, the sample space, and the event B is event B, because B, event B is part of this S. Let's say, what is the common between one student of your class and the classroom? The student is common. Right? So as B is part of this, so whatever part is being covered by B, that is the common part between S and B. Okay, so B is equal to S intersection B. Is it clear?
Yes, sir. Yes, sir.
Yes,
Fine.
sir.
Okay. So if this is true,
Yes.
then move onward. Move onward and write down sample space. So you say that sample space S is if you see the partitions A1, A2, A, so all these partitions, when they are together, they make the sample space. So A1 plus A2 plus A3 up to AK, this is S. So now you may write down over here A1, A1 union A2 union A3 union A4 up to union AK. When you will add all these, what will you have? You will have S. So I am writing down, instead of S, I am writing down this. Right? And then this intersection, and then B. Can I write it down in this way? Yes, I can write down. Fine. So now try opening this. A1, this A1, A1 intersection. So take this A1 and write down this intersection and then B. A1 intersection B. Now this, write down this union, this union. Basically you are writing on A1 intersection B, then union, A2 intersection B, then union, A3 intersection B, then union, so on up to AK and intersection B. So I'm just writing down a few terms. A2 intersection B, union, so on, union, and then AK, AK intersection B. Okay, so I can write it down in this way. A1 intersection B, A2 intersection B, and this U is there in the center, union. Okay. So now, if you see B is there is no subscript with B. There is no subscript with B. But if you see A, subscripts are there, A1, A2. So it means that B remains same, but A changes. Okay. And union is there, so it means addition is there. Union means addition is there. So you can write it down as A1 intersection B, and instead of writing U, you may write down plus, or instead of writing plus, better would be if you take probabilities first. So let me take probabilities first. Then I will write it down, because when union is there and you are going to apply the probability, then you will see that they are mutually exclusive. That I have written in the explanation in the start, that events are mutually exclusive. I have written mutually exclusive. Events AI are mutually exclusive. So this union will take form plus, and we will use the special rule of multiplication when probabilities are there. So let me write down probabilities on both sides. But before that, from here you can see, this may be an extra step, but you may think it. AI intersection B, AI intersection B uh, means A1 intersection B, A2 intersection B, AK intersection B. So these are the events now. This event, this event, this event. And when union is there, it means that these events are mutually exclusive. These are mutually exclusive. This event and this event or this event. So all are mutually exclusive. So if they are mutually exclusive, you may write down over here AI intersection B are mutually exclusive. Okay. Or it is understood, so you may leave it. No problem. Are mutually exclusive, ME. Fine. And when you will take probabilities on both sides, taking probability on both sides of the equation. So what will be the situation? Probability of B, that is there on the left side, and probability of these events. What are the events? AI intersection B, union, or if you write it down as, better would be if you take it as 1. A1 intersection B, union, sorry, probability of A2 intersection B plus union, so on, union, probability of, sorry, union, probability of A K intersection B, A K intersection B. So now you can see I'm saying that the events are mutually exclusive. So you may write down positive sign and you may write down the properties as A1 intersection B plus, simply instead of writing U, simply write down plus sign, A2 intersection B plus so on up to probability AK intersection B. Fine. So now you can see that only subscripts that are there with A are changing 1, 2, 3, so on up to K, but B is same. So you may write it down as, and remember, another thing will be there. You have to solve it for intersection. And remember, for intersection, when you will solve it, you will say that events are dependent. Events are dependent. So here you can consider the events as dependent, and when events are dependent, you will write down probability of A, solving this, multiply by probability of B given A 1 plus probability of A2, probability of B given A 2. So I'm now solving it for intersection. First I solved it for union. I removed the union, simply I put positive sign, mutual exclusiveness. Because of mutual exclusiveness of the events, I put this positive sign. Now I am solving these terms, A1 intersection B. So dependent events, okay, plus so on. And the last event will be probability of AK multiplied by probability of B and AK. Okay, and now you have to see that subscripts are there only with A's, not with B's. So when you will write down this equation in compact form, you may write it down as summation I from 1 to K and probability of probability of AI multiplied by probability of B given I. So now whatever value of I you will substitute in the formula, you will have the term, the relevant term. For example, when you will put 1 instead of I, you will have this term. And summation is there, so you will add the terms. So when you will put here 3 will be there. When you put I is equal to 2, this term will be there. So all these terms that are from 1 up to K, when you will write down this equation in compact form, you will have this. So probability of B, we have proved that probability of B is equal to this. And now see this term. This is the denominator that you have to write down in the base formula. So now the base formula will be like this: probability of AI. I'm writing down it again. This is the base formula. It is equal to probability of AI. Very helpful formula in so many fields. So now you have the proof of this formula, and you also know that how would you use this formula. So instead of writing B that I have written here at this point, this probability of B is equal to, I have proved this. So I am simply writing down this, and then I shall leave the class 1 to k, I from 1 to k, and simply repeat this term: probability of AI, probability of B given AI. So same. So you can see from here. So this is the proof of the base formula. Okay. And here one more thing that is very important to explain over here. This probability is called posterior. And these probabilities that are in form of AI, these are called prior probabilities. These are prior probabilities, and these are conditional probabilities. Understand? So also, if you see, these are the prior, or we also call it prior probability or prior I, and these are the conditional probabilities. Understand? And these are the posterior I or posterior probability. The posterior probability is the probability that we find out when we have some latest information. So when we have latest information and we want to find out something that we have found just that that student passed yesterday. So passed yesterday, what is the probability that he had submitted the assignment? So this will take the shape. After having some latest information, that will be in the in this form, given that this information is given, that latest information incorporated, and you will have the answer. So this is all for today. Thank you very much for your patience. You consumed almost 45 minutes more, so don't worry, this will help you in future. You have not wasted your time. So thank you very much. If you have any question, I may spare 2 more minutes, or otherwise I shall stop recording.
Attendance ले ले sir, attendance.
Okay, sir. Thank you.
Everything is clear. Okay.
Yes, sir. Clear, sir.
सर ये रिकॉर्डिंग भी शेयर करें सर. सर
Thank you very much. I shall
Excuse me,
record.
sir.
I shall share the recording. Don't worry. As I am already sharing all the recordings. No, don't worry about that. Thank you very
Okay,
much.
thank you, sir. Thanks.
Thank you. Thank you.